Nvidia recently achieved a $5 trillion valuation, cementing its status as a market titan. But the stock remains notoriously volatile. In a recent 54-hour window, the market cap surged by $450 billion, only to shed nearly $600 billion shortly after, as investors rushed to book profits. This massive whiplash has fueled anxiety over an AI bubble. High-profile short sellers, including Michael Burry of the Big Short fame, are actively purchasing put options to bet against the company's continuous growth. Wall Street analysts often look at these rapid swings through traditional valuation models, calculating revenue multiples and warning of fragile hardware cycles ready to burst. But evaluating Nvidia strictly through current hardware sales misses the underlying architecture of their business entirely. Nvidia's primary competitive advantage is not its ability to avoid market volatility. It is the executive conviction required to survive long periods when the entire financial establishment bets against them. To understand that conviction, you have to rewind to 2006. At the time, Nvidia was strictly a hardware manufacturer. Their core business was building graphics processing units, or GPUs, which were primarily used to render polygons for PC video games. Then, CEO Jensen Huang announced CUDA. This software platform unlocked the GPU's internal instruction set for general-purpose computing, enabling researchers to run the same linear algebra operations that power 3D graphics at a massive scale. The market reaction was brutal. To support CUDA, Nvidia had to dedicate physical silicon on every consumer chip to double-precision floating-point units. This engineering choice doubled the manufacturing cost of every GPU they sold, while providing absolutely zero performance benefit to the PC gamers who were actually buying them. Huang was deliberately crippling his own operating margins to build a software infrastructure for a computing demographic that did not yet exist. He openly referred to this target audience as a $0 billion market. Between 2006 and 2012, Nvidia poured $100 million annually into CUDA, while scientific computing revenue flatlined at zero. In 2008, a $475 million defect charge collided with the financial crisis. Under this weight, Nvidia's valuation collapsed from $12 billion to $2.5 billion. Wall Street analysts openly questioned Huang's sanity. Institutional investors demanded the company abandon its expensive software ambitions, cut costs, and return to protecting its core gaming hardware margins. Huang refused, prioritizing a business theory known as real options. The company accepted severe near-term losses to secure an exclusive long-term stake in the future of parallel computing. By enduring a 6-year financial gauntlet that would have terrified any rational competitor, Nvidia laid the physical and software foundation for an empire before anyone else even realized the race had started. The payoff arrived in 2012. At the time, academic computer scientists were hitting a physical wall. Standard CPUs execute instructions sequentially, which created a massive bottleneck for researchers trying to process the complex mathematics required for deep learning. A graduate student named Alex recognized a workaround. He realized that to train a massive neural network efficiently, he needed the specific parallel processing capabilities inherent to graphics cards. Because Nvidia had spent 6 years building the CUDA platform, Krzyzewski was able to write custom CUDA code. This allowed him to bypass standard high-level programming and run his computational models natively on 2 consumer-grade Nvidia GTX 580 GPUs. His network contained 60 million parameters, which was too large for a single graphics card to hold. To solve this, he engineered a model parallelism scheme. By splitting his data layers carefully across both physical GPUs, he avoided saturating the computer's internal PCIe bandwidth. Krzyzewski entered his CUDA-powered model, dubbed AlexNet, into the 2012 ImageNet competition. It achieved a 15.3% error rate, crushing the runner-up's algorithm by a massive 10.8 percentage points. That margin of victory established deep learning as a viable academic path. For the market, it meant Nvidia's heavily mocked hardware had become the only computing engine on Earth capable of executing these models at scale. In the months following the 2012 ImageNet results, computer vision researchers began discarding traditional feature extraction methods to universally adopt deep neural networks. Because Krzyzewski's breakthrough used CUDA, major AI frameworks like TensorFlow and PyTorch were built natively on Nvidia's platform. Contrast this with AMD. Their silicon matches Nvidia on raw benchmarks, but locked out of CUDA, their hardware struggles to interface with the frameworks developers actually use. The sheer scale of this invisible moat is staggering. Today, over 3 million developers operate exclusively within Nvidia's ecosystem, writing code that will only run optimally on Nvidia machines. Nvidia's $5 trillion valuation rests on highly advanced silicon, but the empire is secured by a software monopoly. It exists today because leadership had the conviction to fund an invisible, highly unpopular infrastructure project, years before the world ever knew to ask for it.